This video is about integers and rational numbers. In order to be able to do algebra successfully, we need to know about the number system. The first kind of numbers that we are going to talk about are whole numbers, and these are sort of like the counting numbers. You've got your 1, 2, 3, 4, and on and on and on. Those are your counting numbers. Or your whole numbers. The second set of numbers we're going to talk about are integers. And integers include the counting numbers. However, they also include 0, so they include 1, 2, 3, and on and on. But they also include the negative set of numbers, -1, -2, -3, and on in that direction. And then actually 0, I believe, is also included in the whole numbers. Also, or the other set we're going to talk about are rational numbers. And rational numbers are numbers that can be written as fractions. They're written as fractions. And if, for example, 1/2, if I put this into a decimal, it becomes 0.5. So that's a rational number. Or, for example, 1/3, which is equal to 0.333, repeating. 2, for example, is a rational number because 2 can be rewritten as a fraction of 2/1. So there we have our three sets or three types of numbers that we are going to be discussing. Oh, hold on one second. Rational numbers, when they're written as a decimal, in order to be rational, they either have to be terminating or repeating. So, if we look, we see that 1/2 is 0.5. 0.5 is terminating. And 1/3 is 0.333, and on and on and on. And that is a repeating number. Okay, let's switch slides. Alrighty. So, number lines and ordering numbers. You've probably all seen a number line where we have 0. To the right of our number line are our positive numbers, like 1, 2, 3, and to the left are our negative numbers, like -1, -2, -3. So when we order numbers either in increasing or decreasing order, we go back and we rely on the number line. For example, if I was ordering -4, 1/2, 0.25, -1.3, I could order this on a number line to find out the increasing order of the numbers. So let's see here. I've got -4 down here. 1/2 is between 0 and 1, so it goes there. I have 1/2. I've got -4. Then 0.25 is between 0 and 1/2. So that is 0.25. Then I got -1.3. Well, -1.3 is between -1 and -2. So it's -1.3. So if I was writing this set of numbers in increasing order, I would do, for example, -4. Then going along here, I've got -1.3. The next one on the number line, going left to right, is 0.25. It's right there. And then the last one is 1/2. All right. Our next thing that we want to know about is classifying numbers. So when we look at a number, we want to know what kind of a number is it? How could we classify it? Well, if this big square right here is our real numbers, and real numbers are not imaginary, inside our real numbers, we have our rational numbers. Rational. Inside rational, we have our integers. And inside that, we have our whole numbers. Whole. So, if a number is whole, according to my diagram, it's also an integer. If it's an integer, it's also rational. And if it's rational, then it's also real. So let's do an example. Let's say I take the number 4. Well, 4 is a whole number. It is an integer. It is rational. And it is real. So there's an example of a number that's a whole number, it's an integer, it's rational, and it's real. Let's take a look at something like 1.6. Well, 1.6 is a rational number. However, it's not an integer, and it's not a whole number. So we could say it's rational, and it's real. So that's how we classify our numbers. All right, opposites. Opposites are numbers that are the same distance from 0 on the number line in the other direction. So for example, -1 and 1 are opposites. Because they are the same distance from 0 on the number line. They are both the distance of 1. So the opposite of -2 is 2. The opposite of 1,624 is -1,624. Okay, absolute value. Absolute value is pretty much the distance from 0 on the number line. And we don't talk about distance as positive. We don't talk about distance as negative. You can't go a negative distance. Your distance is always positive. Always positive. So the absolute value, and this means absolute value, these straight up and down bars, the absolute value of -3 is 3. The absolute value of 4 is 4. It's because the absolute value of -3 from 0 on the number line is 3. It's 3 spaces. The distance from 0 to 4 on the number line is 4. All right, conditional statements. This is basically an if-then statement. So what you're saying is, if this happens, then something else happens. So an example, let's see here, if x equals -3, then the absolute value of -3 is 3. So that's just a brief discussion of conditional statements. Okay. So some examples. What kind of a number is negative 3? Well, let's see here. Negative 3 is an integer. It's not a whole number because it's a negative, but it's an integer, it's rational, and it's real. Another example, let's order the following numbers on the number line. So, if I drew a number line, I threw a 0 here. So let's see, what are my numbers? I have got 4.3, so let's go 1, 2, 3, 4, 5. So this is 4.3. The next one is negative 0.7, so I'll go negative 1, negative 2, 3, 4, 5, 6. So negative 1, positive 1. Negative 0.7 is between 0 and negative 1. So it's right there. Negative 0.7. Negative 1.7 is between negative 1 and negative 2. So that's negative 1.7. 0 is right there. The absolute value of negative 0.5. Well, the absolute value of a negative, that's positive, so that falls right there. And then I've got 4.13, which is less than 4.3 but more than 4, so it's right about there. Okay, so if I wanted to write these in order, I would do negative 1.7, negative 0.7. Moving along, I've got 0 next. Well, I'm going to cross these out as I go. Then I've got the absolute value, negative 0.5. Then I've got 4.13. And last, 4.3. Okay, you may have noticed in this video that the background pictures in my presentation are far more interesting, and that is compliments of Mariah Draper. See you tomorrow.